Good morning, guys. I'm audible. I'm audible, guys. Hmm. Okay, so today I will be discussing the LeetCode Weekly Contest 487, uh, which just ended. And here's the first question, which is titled Count Monobit Integers. So, as the name suggests, you are simply given an integer n. An integer is called monobit if all the bits in its binary representation are the same. So basically, all the bits must be same in the binary representation of this n. Now you have to return the count of monobit integers in the range from 0 to n inclusive. So, like till n equals to 1, 0 and 1 are monobit because 0 has a binary representation of 0. So all the bits in the binary representation are same, and 1 has a binary representation of what? 1. So that also has all the bits same, right? So the answer is 2. Now till n equals to 4, all the numbers binary representation has been listed. And if you see 0, 1 and 1 1 are valid and 1 0 and 1 0 0 are not valid. So the answer is 3. So we have to print the number of monobit integers up to n. That's the question. Now, if you carefully think about the question, so what kind of numbers do you want? What kind of numbers do you want? That's the question actually. Right. So, so yeah. So what kind of numbers do you want? You want numbers of the type 0 or right? Because you want all the bits in the binary representation to be the same. So this is the binary representation of monobit integers. I hope that is clear. So what is the number which has such a binary representation? Are there multiple numbers possible or is there just a single zero possible? Only zero is possible, right? Only zero is the one that has this kind of a binary representation. But now what about this thing? So this thing could be, if you carefully imagine, one, currently I'm writing just the binary in binary. Okay, so we could have one, we could have one one, we could have one one one, we could have one 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 one, we could have one 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 one, so on, right? So all of them will be monobit integers. Now, what is the speciality about these numbers? What is the speciality about these numbers? So if let us say I add one to any of these, what will happen? In binary, if I add one to any of these, how will they look like? 1 plus 1, 1 0. 1 1 plus 1, 1 0 0. 1 1 1 plus 1, 1 1 0 0 0. 1 0 0 0. So what is happening? These are what? These are powers of 2. These are what? These are powers of 2 simply. So what do we require? We, what are these numbers? These are just nothing but 2 to the power something minus 1, right? 2 to the power something minus 1. Even if you write them in decimal, what will happen? 1, then 1 1 is 3, which is 2 to the power 2 minus 1. 1 1 1 is 7, which is 2 to the power 3 minus 1. 1 1 1 1 is 15, which is 2 to the power 4 minus 1. 1 1 1 1 1 is 31, which is 3 to the power 2 to the power 5 minus 1. So this is nothing but these are just 2 to the power n minus 1, right? To the power n minus 1, where n is greater than 0. Even if you carefully observe, uh, for 0 also, 0 is also 2 to the power 0 minus 1 only, right? 0 is 2 to the power 0 minus 1. So you can simply say n is greater than equal to 0. 0 is also what? 0 is also what? 1 minus 1, which is nothing but 2 to the power 0 minus 1, right? So these are just 2 to the power n minus 1 type of integers, and you have to count them up to a given integer n to the power x minus 1, let us say. Right. So I think the logic is quite clear right now. If you have any problem with the logic, please tell me. If you have any problem with understanding why these numbers are 2 to the power x minus 1, please tell me. If you have any other problem, you can also tell me that in the chat box itself. So, yes. Uh, so, now, if you do not have any problem, we will move on to the implementation part of this. So, what will happen? First, so for the implementation, you have to think what you just have to count up to n, right? So if I store these kind of numbers in an array, these kind of numbers in an array, right? uh, these kind of numbers in an array, so I can just use a lower bound, upper bound, or a binary search kind of a thing to find how many integers are actually less than this, right? So what if I have an array like 1 3 7 15 31 63 127 255 and then 511 and then 1023, only till here, because n is less than equals to 1000. So you just need these integers, right? So, and you can also have 0 in this. These are the valid monobit integers, right? Monobit integers. So if I have to uh, find number of monobit integers up to n, where let us say n equals to 4. So I just need to count these three, these three. So what will I do? I will just move to a number that is greater than 4, right? So 7. And I will see what is the index of 7, right? So index of 7 is 0 1 2 3. So index of 7 is 3. So there are three integers less than 7, three integers less than 7, and that is the answer. Now let us say we will have an edge case. Let us say I will ask you up to n equals to 7. So will I go will I take the index of 15 or will I take the index of 7? That's the question, right? So let us say I take the index of 7, then there will be three integers, but that is wrong because 7 has to be included as well. So you will have to print the index of 15 right now. So you always have to find the index of a number greater than n. Find the index of a number greater than n in this array. So this is the array V. This is the array V, right? So I think you got this concept. Now, how do you find the index of a number greater than n? This is, you must know the, you can either count it as well. You can simply, because since this is just an array of size 10, you can simply count it as well, or you can use the upper bound function as well. So a little bit of binary search, if you know, uh, then you might also be knowing about the upper bound function. So upper bound function of a number returns the number greater than n. So like for 7, it will return this 15. And if you subtract 15 and v dot begin, you will get the index of this 15, right? So that is what I have done. You can simply start it with 0 as well and return this in the in the end. So I will show you how the array looks like first of all. So let us see how the array looks like. C out v of I, right? C out v of I. So yeah, this is how the array looks like, right? This is what we wanted, monobit integers. So what can I do to make it simple for you guys? I will um, write it even more simply. So I had a vector v, and I want these 2 to the powers. So what will I do? V dot push underscore back, push underscore back what? Um, V of no. So 2 to the power I minus 1. Just a second. Right, 2 to the power I minus 1. You can push back into the array, and then you will get the desired array, and then you can simply have what? You can simply have upper bound. Upper bound will return the the point to a number greater than n, and this will return the index of that number, which is the answer which we want, right? Which is the answer which we want. We want the index of the number greater than n, which is upper bound minus v dot begin. So, like if I run this, it works. Let's submit it as well. So yeah, it beats all the time complexity as well. So this is more or less a solution to the first problem. I hope you understand the solution quite clearly. So yeah, let's move on to the next question now. Uh, so people are talking. Fourth one is really tough. Okay, we will discuss the fourth question as well. It's not that tough. Um, okay, so this is the second question. Final element after subarray deletions. So in this question, we are given an integer array nums, and we are given two players, Alice and Bob, which play a game in turns. So Alice plays first, and Bob will play alternately. So you're told that the current player chooses a sub array nums L to R. So you choose a sub array which has the index from L to R, and the length of this subarray is obviously less than the current length of the array. Basically, this means that you cannot select the whole array at once. You always have to leave some element. You cannot select the whole array at once. Okay, so so you select some subarray, some proper subarray uh, of this nums array, and you remove it in a move. In a move, you remove it, and then the remaining elements are concatenated to form the new array. Now I will tell you what this means. So like we have, let us say, an array 1, 2, 3, 4, 5, 6. Okay. So what I can do is I can remove a particular subarray. Remove a particular subarray. How will I do that? So subarray is what? Contiguous elements. So basically 2, 3, 4 could be a subarray. This 4, 5, 6 could be a subarray. 2, 3, 4, 5, 6 could be a subarray. 1, 2, 3, 4, 5, 6 could be a subarray, but that is not allowed. Since you have to take the length of the subarray to be less than the current length of the array. So you cannot take the whole array at the same time because you would be removing the current subarray. Okay, so the selected subarray is removed. So like if I remove 2, 3, 4, this will happen, and the remaining elements are concatenated to form the new nums array. So this game will continue until only a single element remains. So that is what we want in the game. Okay. So Alice aims to maximize the final element while Bob aims to minimize it. So assuming that both players play optimally, you have to return the value of the final remaining element. Now, a subarray is a contiguous non-empty sequence of elements within an array. So yeah, that is something I told you. It's a contiguous non-empty sequence. And in this case, I've told you the definition of subarray as well. Now, let's move on to the logic of the question. So, uh, like like I told you, like I told you, if I have a subarray 1, 2, 3, 4, 5, 6. So, sorry, this is the array nums. Let us say I'm Alice. Let us say I am Alice, and Bob is my opponent. Now, what will happen? Uh, Alice aims to maximize the final element. We have to remove the elements until only one element remains, and I want to maximize the final element, and my opponent wants to minimize it. Right? So, what will happen? What will happen here? So, I am Alice. Bob is my opponent. Now, 1, 2, 3. Let us say I say that I want to remove 1, 2, 3, 4, 1, 2, 3. Okay. So I remove 1, 2, 3, but I had to maximize the final element, right? So let us suppose this I remove 1, 2, 3. I will maintain a copy of nums array right here. 1, 2, 3, 4, 5, 6. Let us say Alice removes this. Now Bob will see that okay, 1, 2, 3 have been removed, and I want to minimize the final array, right? So what can it do? He sees that the minimum element is 4, and he can make it as the final element of the array. So what will happen? He will delete these two, and 4 will be the final element. But is it optimal for Alice to choose the first subarray? Because this is just an example of a game that we could play. So what will happen in reality? Let us come to that now. In reality, what will happen? Alice will see that 6 is the maximum element, and as Alice, I will try to obtain the 6 as the final element. So I will see, can I remove all the elements except 6 at once so that 6 is the final element? So yeah, I see that I can. So I remove 1 to 5, and I'm simply left with what? I'm simply left with 6. And now Bob cannot remove anything because only one element is left. So the final element will be 6, and it is obviously maximized by Alice. So this is the strategy that Alice follows in this test case. Let us say now I just have a single element. So we do not play any move, right? We do not play any move and simply return this single array. So let us I mean to say that let us say this was nums, right? This was nums. Now if you understood uh, these test cases, first of all, one thing is clear that if nums has only one element in it, you can simply return nums of 0 or the single element that was originally there in the array. This thing should be really clear right now, because if there is a single array, you cannot, Alice or Bob, both cannot make a move, right? Okay, so the single array thing should be clear right now. Now, what about the multiple elements in the array? What will happen in that case? So, in that case, 1, 2, 3, let us say I have this 1, 2, 4, 3. Now, Alice will want the final answer to be 4, and Bob will want to minimize it. So it will want that the final answer is what? 1, right? Now, the question is, can Alice ever obtain, can Alice ever obtain 4? Because what will happen if Alice wants to obtain the element 4? Alice will remove this because obviously anything except 4 should be removed. And then Bob will see that Alice wants the final answer to be 4, but you have a number 3 available. So Bob will do what? Bob will erase this 4, and the final answer will be 3, right? So the final answer will be 3. So the thing is, any element in between cannot be achieved by Alice. Any element in between the array cannot be achieved by Alice because Bob can eventually delete that. Bob can eventually delete that, right? If you cannot understand this, I will tell you again. Alice can't obtain any element not lying on the extremes of nums. Extremes of num means either on the left corner or on the right corner. So Alice can obtain this one if it deletes all these numbers. Alice can obtain this 3 if it deletes all these numbers, right? So that's the idea. So Alice can obtain this thing only. Now what will happen? Uh, so Alice will try to get the maximum of these two because these integers are not available for Alice. These are not available for Alice, right? And now, uh, so yeah, obviously we know that Alice can make the first move and get the answer as max of extremes. So obviously we know that max of num 0, comma nums of n minus 1 is the answer for sure, right? So can Alice do anything better than this? Because Alice has got the first move. Can Alice do anything better than this? Because Bob cannot reduce it from here because Alice has the first move, and this thing itself can be obtained in the first move. Now the question is, can Alice get an even better answer? No, because the middle elements cannot be obtained as the final answer, right? Middle elements cannot be obtained as the final answer. Why? Because they will require two moves. They will require two moves. So, like I wanted to achieve 4, I have to remove these two subarrays, and for removing two subarrays, Alice will require two consecutive moves, which is not possible, and Bob will interfere in between surely. So the middle elements cannot be obtained by Alice. So this max of num 0, nums n minus 1 has to be the final answer for sure. Right? Right. Any problem in this question? because you might have done this question uh, by some guesswork as well. But yeah, the main thing to observe was that middle elements cannot be obtained, and Alice can obtain this answer in the first move itself. So yeah, this is more or less the logic for this question, and the implementation is not a big deal in this question. If the size is just one, you can return the first element. Otherwise, you can return the max of extremes, right? Uh, so yeah, that's the idea. Let's submit this question. So yeah, this works. Beats all the time complexities. So yeah, let's move on to the next question now. They have, if you do not know object-oriented programming, it's not a big deal. I will tell you how much it is required in this question. But yeah, let us first of all read the question what it says. A ride sharing system manages ride requests from riders and availability from drivers. So, like you are working in Uber and you want to maintain a ride sharing system. So, riders will request rides and drivers, if they are available, they will accept rides, right? So, riders request rides and drivers become available over time because drivers might be busy somewhere else as well. So, mi- um, and drivers might become available over time. The system should match riders and drivers in the order they arrive. So the system should match riders and driver in the order they arrive. So this simply says if a rider comes first, it should be assigned a driver first. And if a driver is available first, it should get a rider first, obviously. So this line just means that this is a first come, first serve system. So this sentence obviously points to the data structure that you must use. Wait a second, wait a second. Yes. Yeah. I was telling you that this line itself points out to the data structure that we must use in this question. Uh, because this line says that a first come, first serve system has to be established, right? So what will happen? These are the implementations that the question asks us for. So first of all, this is the constructor of the class, which will initialize the system. Okay, this will initialize the system, and then there is a void function add rider, which will add a new rider with the given rider ID. And then there is an add driver, which will add a new driver with the given driver ID. Okay, and then there is a match driver with rider function, which will return an integer array, which will return an integer array. So this is nothing but you will return driver ID comma rider ID if a match is made. Otherwise, if a match is not made, when will a match not be made? If a driver is not available or if a rider is not available, a match cannot be made, obviously, right? So it will return -1 comma -1 in that case. And then this is void cancel rider. So this will cancel the ride request of the rider with the given rider ID. What does this mean? What does this mean? So this simply means that like in Uber, if I first of all booked a ride, but then I suddenly realized that I do not have to go to this place. Many times it happens that we have to cancel a ride, or maybe let us say there is a problem, there is a delay at the driver's end as well. So let us say the driver is coming late, so I want to cancel the ride. So this is a function for canceling the ride right now. So this cancels the ride request of the rider with the given rider ID. So you will be given the rider ID that has decided to cancel the ride. So if the rider has, if the rider exists and has not been matched, you will cancel the ride request of the rider. Right. So one rider will come only once. These are some constraints of the question. So the IDs are till 1000. There are only 1000 queries as well. So you can use an n-square solution as well. 1000 queries, 1 is 6 is a valid time complexity. Right. So n-square solutions are allowed in this question. Each driver ID is unique and each rider ID is unique. Yeah, that's the thing. So one rider is added only once, and one driver is also added only once. So this makes the question simple because in companies like Uber, this question would be a difficult one because the riders are, uh, although the rider ID is unique, but the riders could be added more than once, right? But in this case, a driver is added once and the rider is added once. So it's a simple question. So first of all, since I told you this is a first come first serve system, we will have to use a queue data structure because it has the definition of first come first serve data structure. If you do not know the basics of queue, I will explain you right away. You do not need to worry about anything. Um, yeah, first of all, I will be discussing the O of n square solution, and then I will also tell you O of log n log n approach as well for this question. Although I've implemented the n-square solution as well due to the time constraint in the contest, but I will be explaining the O of n log n solution. Don't worry. So yeah. So what will happen? What is the queue data structure I was telling you, right? So what is the queue data structure? So a little bit idea is enough for this question, but it's okay if you do not have any idea because I'm still explaining. So a queue data structure looks like this. Looks like this. Let me What is a queue? Queue is a like you stand in a queue for booking a train ticket, right? So it is just a line. So let us say I am at this place and the booking counter is here. So this means that I came first, so I will be served first and sent first, right? And when I have to enter, I will enter from the back side. So like entry is in this direction from the back side and exit is from the front side, right? So this is how a queue data structure works. So Um, so for this one, this thing, you use a dot push function, dot push function, and for this thing, you use a dot pop function, dot push. Let us say a person X arrives, so dot push X and dot pop will simply remove this person from the queue, right? So this is how the queue structure works. So we have made two queues, one for drivers and one for riders, right? Because we want to assign drivers to riders. So we need a queue data structure for both of them. So while initializing the system, this is the constructor. You just make the queue an empty queue. So this is redundant, but a constructor is necessary for a class. So you just have to write something. Yeah. Now comes the add rider function. So what will happen in the add rider function? You just want to add a rider to the queue. So what will happen? You will just say dot push the rider ID. And to add a driver, you will say drivers dot push driver ID. Yeah, right. In this way, we insert them into the queue, into the waiting queue. Right. Now we have made the match driver with rider function. So what will happen? So let us say I have this riders queue. So let us say rider number one, two, and three are waiting here. And let us say I have a driver's queue as well. And driver number 5 and 4 are waiting here. So what will happen? So this 5 would have come first and this 1 would have come first. So if I ask you to make a match driver with rider function, so what will happen? One rider will be assigned to driver number 5, correct? Because they have come first. So what will you do? You will simply pop both the elements from the queue and return what? Return what? Return driver ID comma rider ID. So you will return simply 5 comma 1. And how do you access the first element of the queue? So to access, so if I want to know what's the name of this person, so the name of this person is given by dot front function in the queue. So if you are not aware about the queue and data structure, it's not that difficult to understand this while I'm telling you, right? So dot front gives you the name of the person, name of the person. Dot push will insert a person into the queue. Dot pop will remove the person from the front of the queue. These are the functions of the following functions of queue data structure, right? So, uh, yeah, this is more or less the 5 comma 1 will be returned in this case. But what if, let us say I had, let us say I had riders 1 comma 2 comma 3. Let us say I had riders 1 comma 2 comma 3, right? Let us say I had them. And let us say I also had drivers, but there is no driver that is currently available. So drivers are currently unavailable. Drivers are currently unavailable. So what will happen? If the drivers are unavailable and I call the match function, so rider cannot be assigned to a driver. So what will happen? A match cannot be made. So you will return, simply return what? Minus 1, comma, minus 1. That's what is asked in the question. So how will you implement it? So simply if the riders is empty or the drivers is empty, so you cannot make a match. You cannot make a match. So you return minus 1 comma minus 1. And now D is in the front of the drivers and R is in the front of the riders. So like this is R and this is D. So you will return D comma R, but and before returning you will remove the first element from both of the queues, because if you do not remove uh, the so basically you have to remove it, right? Because otherwise the next match will also be the same. The next match will also be 5 comma 1 5 comma 1, and the rest will never be at the front of the queue. So you have to pop 1 from the queue of riders and 5 from the queue of drivers, right? So this is how the match driver with rider function is implemented. Now the last one is cancel rider. Now yeah, the problem is all the other all the other takes, so even add rider and add driver will take off 1 complexity, and this will take off 1 complexity at the same time as well. But this cancel rider will take off n time complexity. Cancel rider will take off n time complexity. So what is the approach? So like I told you that I had let us say rider 1 2 3 in my queue. Okay, if I have these 3 riders in my queue, and now I decide to now let us say that rider number 2 decides that he wants to cancel the ride because he is getting late. So he will say that Uber, I will not use your app, I will cancel your ride and book Rapido. This is what 2 says. So he wants to cancel the ride. So what will he do? What will we have to do? We will have to make the queue as 1 comma 3, 1 comma 3. But the problem is I cannot simply remove it from the queue until I know its position. And even if I know its position, what will happen? First of all, I will remove 1, then I will remove 2, and then I'm left with only 3 in the queue, which is not which is not what I want, right? Which is not what I want. I want 1 comma 3 in the queue. So I will have to use some extra space. I will make a temporary queue which is empty right now. Now what will happen? Now what will happen? I will pop an element from this and insert it into this. I will pop an element from this and insert it into this. But this too, when it is popped, since it has cancelled the write, this will not be inserted into the temporary queue, right? So this will not be inserted into temporary queue. 2 is just removed and not inserted. Then we come to 3. 3 is removed and inserted here. So 1 comma 3 is left in the temp. 1 comma 3 is left in the temp. So simply you remove an element from this queue and insert it into this queue, given that element the element is not the rider id which cancelled, right? Rider id which cancelled. So this is more or less the idea of the question. So that is what I have done right here. So I make a temporary queue, and then I will empty the rider's queue, empty the rider's queue, and push every rider into the temp if the rider has not cancelled. Uh, Push into temp if the rider has not cancelled. And which rider has cancelled? Rider ID has cancelled. So if riders dot front is not equals to rider ID, I will have to push it. Otherwise, I do not have to push it. I just have to pop. And pop is done for everyone, right? Because you will pop 1 and then you will insert it here. You will pop 2 and then it is equal to rider ID, so you will not insert it here. You will pop 3 and then you will insert it here. So the pop has to be done no matter what, but the push is done only if the rider has not cancelled, right? This is the solution to the problem. And then uh, now let us say that even if rider was added multiple times, this O of n solution uh, will will still handle it, because let us say 2 was even here as well. Two had booked, let us say, two rides, and it wanted to cancel both of them. So 2 will cancel this ride and this ride as well, because 2 will again not be inserted into the queue. So in this question, you do not need to think much about it, since all the drivers are added once and all the riders also added once. So yeah, this is more or less the solution. And finally, what you will do, you will update the riders, right? Because the riders is currently empty, which you do not want. So you will update the riders equals to temp, which makes sense because riders is the member of class, so it cannot be, it cannot be corrupted during this function. Because if after this loop, the riders will become empty, so you just have to update it again with the temp. And this is more or less the idea of the question. Now I will be explaining how you can think about the O of login approach per query. O of login approach per query. So for that, I won't be implementing the approach, but I will give you a simple idea. So what you will have to do is, what you will have to do here is that you might have to implement a linked list and a hash map at the same time. Linked list and a hash map at the same time. So if I had this one, like in the form of linked list, I had riders. Okay. right? So if I had the riders in the form of a linked list, so and what will I do? I will make a hash map integer to node star. So basically, I want to know. So map. This will map what? This will map what? Map maps rider ID to linked list node pointer, right? So what will happen? Now I know. So if I know rider ID, I will be able to know. Let us say this is named. This is named. Let us say MA. So if I know a rider ID right now for canceling the ride, what will happen? If I know the rider ID, what will happen? So MA of rider ID will give you what? A pointer to this node. A pointer to this node. And the thing is, you need a doubly linked list here because you need to know the previous element as well. Doubly linked list. Okay. So what will happen? If you are not aware about linked list or doubly linked list, it's okay because that is why they have already allowed O of n squares of n solutions per query in this question, right? So you if you just want to know the login solution, I'm telling you. So this map will introduce the login term, right? So what will happen? So you know the this address, right? So what will happen? Uh, Let us say I name this as a variable node. Okay, this is as a variable node. So I will say how will I delete this node from this? I have to delete the node. So node previous का next. So basically node का previous क्या होगा? 1 and we will say that since we want to delete this हम कह देंगे कि 1 का next अब बन जाएगा 1 का next अब बन जाएगा 3, right? So node के previous का next क्या हो जाएगा? It will be node का next. And और क्या कर रहे हैं? Since this is a doubly linked list, तो ये कनेक्शन तो हमने तोड़ दिया, ये कनेक्शन हमने तोड़ दिया, ये कनेक्शन ये कनेक्शन तोड़ दिया, अब हमें ये कनेक्शन भी तोड़ना है, राइट? सो व्हाट विल आई से कि 3 का प्रीवियस को 1 बना दो. सो हाउ विल आई राइट इट? 3 के प्रीवियस को 1 बनाना है. सो दिस मीन्स कि नोड के नेक्स्ट का प्रीवियस इक्वल्स टू नोड का प्रीवियस, राइट? सो सिंपली इस नोड का अब कोई सिग्निफिकेंस नहीं आ जाएगा बिकॉज 1 will point to 3 and 3 will point to 1. And also लगे हाथ मैप में से भी इसको रिमूव कर देंगे. सो एम ए डॉट इरेज व्हाट राइडर आईडी कॉमा नोड, राइट? कॉमा नोड. सो यहाँ मैंने बताया नोड क्या था, ठीक है? तो ये since this will not remain in the map anymore, so I will remove it as well. So this will be the cancel ride. This is the cancel ride function. Now, what about the other functions? So for this thing, initialization is just redundant because again, you will initialize with the empty linked list, right? The drivers could be still maintained as a queue, but the riders will be implemented as a linked list in the OAuth login solution. And to add a rider, what will you do? So to add a rider, you will insert at the end of the linked list, which you can easily do because you will have the address of this last node. So you will simply say So you will maintain a pointer, right? So you will have to maintain two pointers, which is head and tail, head and tail, right? So what will happen when I add a rider, add driver function will not change because I told you that driver will still be a queue. Driver will still be a queue. How will be the add rider function updated now? So तो तुम्हें क्या करना है कि tail का जो next है, it will be it will be what? Tail का next will be the is equals to new node जिसका rider ID वैल्यू होगा, ठीक है? न्यू नोड राइटर आईडी एंड टेल का सॉरी एंड ओके सो मैं एक नाम दे देता हूँ उसको पहले नोड स्टार node equals to new node driver ID. So node is basically an object of so node is the name of the linked list class. Okay, so node हमने एक नई node बना दी and we will say that tail का next होगा अब ये node and इस node का previous होगा जो tail है and the new tail will be this node because it will be at the end of the so this will be the add rider function. So you should be thoroughly aware about the linked list for the login approach of this question. I have just discussed in case you are curious if it could be done in a better time complexity. Otherwise, you are just good to go even if you know about the queue data structure, right? For this question. So this is how the add rider function will be made. And then uh, the match driver function is almost the same. You just have to remove the head of the linked list instead of removing the front of the queue of the writers. Okay, so I will not be going into much details and implementation of the question. I just had to give you a simple idea how the linked list solution helps to give you a O of login approach, which might be important from the interview point of view for this question, right? So yeah, I hope this question is quite understandable to you all. Okay, so yeah, Desi Ashwin has asked, isn't it better to make all login time complexity? So yeah, I have told you the approach how to make login time complexity as well. Um, yeah, this was about the n square approach. Okay, yeah. Now the last question. So it's a lead code hard question. So you are basically given the question says longest alternating subarray after removing at most one element. So this question, although it says it's hard, it's actually a simple question if you are aware a bit about competitive programming questions. Uh, not not much related to DSA, but yeah, for competitive programming people, it's a very easy question, I guess. So you just want alternating subarray. Now, what is the definition of an alternating subarray? So this means less than, greater than. Okay? Like what I mean to say is that 2 1 तो यहाँ पे क्या है ये वाला साइन है अब ये वाला साइन आना चाहिए तो लेट अस से 2 1 3 and then 1 and then 4 तो ये एक alternating सब array बन चुका है okay so a subarray is alternating if one of the following condition holds and okay and now so nums of L uh, they have just defined it so basically you have less than greater than or greater than greater than less than ठीक है बड़ा छोटा या फिर छोटा बड़ा now in other words if we compare the adjacent elements in the subarray then the comparisons alternate between strictly greater and strictly smaller. So this is just the statement written in English. Okay. So you can remove at most one element from nums. तो एक element आप सिर्फ remove कर सकते हो, which is a quite a good hint for the question. For the brute force thing we can apply in this question. कि हर element remove करके देख लो because O of that will that will take just O of n time, right? So since you have to remove at most at most one element. So in questions like these, you can think of the brute force approach because if you just want to remove one element, why not try to remove every element, right? So brute force मतलब यही कि हर पॉसिबिलिटी ट्राई कर लो. At most one element remove कर सकते हैं. Okay, I will try to remove all the elements I possibly can, right? So then you select an alternating subarray from the nums array. So alternating subarray आपको अब उसके बाद nums में से चुनना है which has the maximum length. So you have to return the maximum length of the alternating subarray you can select after removing at most one element from the nums. I guess the language of the question is clear. Now we will be discussing the logic to the question as well. Okay, so this question, as I told you, from the DSA perspective, it's okay. Competitive programming के लिए, it's a quite a simple question. Okay, so okay, so एक बात आपको सोचनी पड़ेगी. Since I told you कि remove at most one element from the nums, so why not think of the brute force approach? Ki we will try to remove all the elements from the nums. So let us say I had this array. Let us say I had this array. तो ये array मेरे को मान लो दिया हुआ है. तो पहले तो without removing an element, let us think about the longest alternating subsequence. तो 3 2 1 तक नहीं जा सकता, 3 2 होगा सिर्फ. तो 2 लेंथ आ जाएगी इसकी. 2 1 2, बट फिर 3 तक नहीं जा सकता बिकॉज 1 इज लेस देन 2 एंड देन 2 इज लेस देन 3. तो ऑल्टरनेटिंग नहीं रहेगा. सो 2 1 2 3 लेंथ आ जाएगी, राइट? एंड देन 1 2 3 तक नहीं एक्सटेंड कर सकते, 2 लेंथ आ जाएगी. एंड देन 2 3 2, बिकॉज 2 इज लेस एंड देन 3 इज ग्रेटर. सो 2 3 2, बट 1 तक नहीं एक्सटेंड कर सकते बिकॉज 3 is greater and then 2 is also greater. So 2 3 2, so again 3 length, and again 3 2 क्योंकि 1 तक नहीं जा सकते, and again 2 1. So the answer is currently 3 अगर मैंने कोई एलिमेंट रिमूव नहीं किया. Without removing an element, एग्जाम्पल सब एरेज क्या होंगे? 2 1 2 एंड 2 3 2, राइट? तो साइन लगा दो ना सीधे, ग्रेटर लेसर एंड लेसर ग्रेटर. ठीक है, एग्जाम्पल सब एरेज भी आपको बता दिए so that you get a clear understanding of the test case. So yeah, this is the next thing. तो अभी मैं रिमूव करके देख सकता हूँ, राइट? तो लेट अस से आई रिमूव. देखो एक बात है कि if I remove the corner elements, it's of no significance, right? Corner elements remove करके सारा array बाकी का वैसे ही रहेगा. It could reduce your answer, uh, but can never increase the answer. So there is no point of deleting the corner arrays because क्या होगा? 3 delete करने से क्या होगा? कम हो जाएगी लेंथ array की और कुछ नहीं होगा. You cannot find a better answer in that way, right? So corner elements मत remove करो. Let us say I remove 2. If I remove 2, the array will look like 3 1 2 3 2 1. तो अभी भी क्या होगा? So 3 1 2 हो सकता है एक एरे, राइट? 3 1 2 एक एरे हो सकता है अभी भी, और 1 2 हो सकता है, 2 3 2 हो सकता है. स्टिल द आंसर विल बी 3. एग्जाम्पल 3 greater than 1 less than 2, and 2 less than 3 greater than 2. So this is if I remove this 2. Now if I remove this 2 right here, if I remove this 2 right here, what will happen? So 3 2 1 3 2 और 1. अभी आप देखो आंसर क्या हो जाएगा. आंसर हो जाएगा, आप इस बार ही देखना, 4 हो जाएगा आंसर. और एग्जाम्पल सब एरे जो है इसमें, 2 इज ग्रेटर देन 1 इज लेस देन 3 इज ग्रेटर देन 2. तो लाइक आपने ये एलिमेंट डिलीट करके कुछ तो बेटर आंसर आपको मिल गया, राइट? सो यू गॉट अ बेटर आंसर बाय डिलीटिंग दिस टू इन दिस nums array, and then you are asked to find the maximum length of the alternating subarray if you can remove at most one element. So ठीक है, अब मैंने ये कहा कि we will try to remove one element. तो how would we know that after removing that one element, what better answer I have obtained? What better answer I have obtained? तो एक चीज इमेजिन करो, अगर मुझे पता है कि ये टू रिमूव कर रहा हूँ मैं, if I know that I am removing this two, so I want to know that uh, I will be concatenating some subarray in this direction and some subarray in this direction, right? So can I combine the two subarrays together? So like I know that this is an alternating subarray and I know that this is an alternating subarray, but after removing this, I just want to know that can I concatenate this and this, right? Can I concatenate this and this? In this case, yes, I could, because this was greater, and this was lesser, right? So in this case, I can concatenate for sure. Okay, so now think about this. Ki, how do I know? So I just want to know the answer of the length of subarray to the left from from this position, and to the right from this position, to the right from this position, right? So we will have to maintain two arrays. You can say that this is dynamic programming question. So एक सब array we will maintain the first sub array vector of integer LAS. So LAS means left side alternating sub array ending at index I. LAS of I will give the left side alternating sub array ending at index I. But the thing is, the sub array will end in what way? That's the question, right? Now what I want you to imagine is that the array could have ended at a greater sign. Like in this case, it ended at a greater sign. I removed 2 and this ended at a 2 greater than 1 greater sign, right? So, and the array could also end like this, less than, greater than, less than. So array could have also ended at a lesser than sign. So why not maintain two integers? So what I'm talking about is that why not maintain a pair of integer comma integer? So what do I mean? Left side alternating subarray ending at index I with a sign greater than, comma, with a sign less than, right? So like if I ask about this one, so ending at sign greater than will be a length of 2, right? Because 2 is greater than 1, so it will be a length of 2. And at 1 ending at 1 with a sign of less than, is it possible? Because 2 is greater than 1, so it's not possible. So इसके क्या होंगे contents इस index पे if I ask you? So v of 0, LAS of 1, LAS of 2. So what will be LAS of 2? LAS of 2 will look like, LAS of 2 will look like 1 comma 2. Okay. 1 comma 2 greater than sign, sorry, 2 comma 1. So ending at a sign of greater than and at index 1 will be a size of 2, and ending at index 1 with a sign of less than will be a length 1. Length 1 तो ले सकते हैं because it is just a single element, right? So LAS of 2 आपको समझ आ गया होगा. Now what about RAS of 4? Now what is RAS first of all? The question arises. RAS क्या है? So to LAS, similar to LAS, now RAS is a right side alternating subarray. Right side alternating subarray, right? Right side alternating subarray ending at index I with a sign of greater than, uh, comma with a sign of lesser than. So RAS of 4 देखना था हमें. RAS of 4. For convenience, I will tell you इसको उल्टा रख लो because we will be using just a single function to compute both LAS and RAS. I will discuss that thing later. But अभी के लिए imagine करो कि the first one will store ending at sign lesser than and second one will store ending at sign greater than in this RAS. Okay. So what will happen? RAS of 4, so 0, 1, 2, 3, 4. तो इस पे end करने वाला with a sign lesser than. So 3 is greater than 2. So again, what will happen? इस पे end करने वाला है ना, right? So इस पे या फिर ending at index I नहीं, इसको लिख देंगे starting at index I. Starting at index I. So 3 हो गया with a sign of lesser than. 3 with a sign of lesser than. So you cannot extend the array further. So 1, right? And 3 with a sign greater than. So 3, 2, फिर आगे 1 तक नहीं जा पाओगे because दो बारी greater than का sign. So you will alternate 2 greater than consecutively. So you cannot go further. So 3 comma 2, which is 1 comma 2 आ गया. Okay. So this is the thing which you have to consider. So what will happen? Now if I want to ask you that, okay, you remove 2. You remove 2. So can you concatenate? How can you concatenate this? So first of all, you will see what कि 1 और 3 में क्या relation है. Because you need to know that how can they concatenate, how can they be concatenated. So we come to know that nums of 2 is less than nums of 4. Nums of 2 is less than nums of 4. So basically, the signs should look like greater than, less than, and greater than. Right? Greater than, less than, and greater than. So what do we have to take? LAS का greater than वाला part and RAS का भी greater than वाला part, right? Because the sign in between them is what, less than. So yeah, that is the thing. So LAS का greater than वाला part will be 2 and RAS का greater than वाला part will be 2. So 2 plus 2 answer will be 4. This is how you had to imagine the question. Okay. So uh, if you are thinking कि how I came up with this logic, तो इसको bit by bit सोचो. uh, that first of all I need to know कि I am removing just a single element at a time. So I must know that I can use a brute force. I can try to remove every possible element. Now, if I try to remove every possible element, there will be some concatenations. And when I try to concatenate, I need to know how the array looks like to the left of the element I delete and how the array looks like to the right of the element I delete. And that is why I am maintaining a left alternating subarray and a right alternating subarray. And now I also want to know how does the last element look like? Is it a less than sign or is it a greater than sign? So I'm storing these two elements in these subarray, these LAS and RAS. Okay. So this thing must be clear. So the final thing is clear to you that yeah, what will I do finally? Ki I will run a loop. I is less than n minus 1. So I will just go, I will just not take the corner cases, the corner elements, right? Because I already told you ki, if you delete the left corner or the right corner, there is nothing happening, right? So now see this. So what will I do? If nums of I minus 1 is less than nums of I plus 1, then my answer will be max of answer comma. So answer will be basically the length of the subarray, right? So answer comma what? LAS of I minus 1 plus I minus 1 dot first plus RAS of I minus 1 dot second. This is the case that we have discussed because less than वाला sign बीच में आ गया, so I need greater than signs to both the sides, right? And else if nums of I minus 1 is greater than nums of I plus 1, then what will happen? Why did I not use else? Because I do not want the equals to part to be included, right? The elements could be equal, and in that case they cannot be concatenated because all the inequalities here are strict. So that is why we have to use else if nums I minus 1 greater than nums I plus 1. So basically this means that we want less than greater than less than, right? Less than greater than less than, so greater than in between. So I want the less than from the last one and less than from the right side one also. So max of answer comma LAS of I minus 1 dot second plus RAS of I plus 1 dot first, right? So yeah, this is the thing, right side alternating subarray. But now I have flipped this thing. So this was greater than less than, and this is less than greater than. So now you will understand why I have flipped this thing when I will tell you how to construct the LAS and RAS array. The final thing would be clear that what is the idea finally. Now the thing left to do is just the construction of this LAS and RAS. So if you imagine, if you can construct LAS, RAS is nothing but the constructing LAS of the reverse array. RAS is nothing but constructing the LAS of the reverse array. Think about it carefully. Think about it carefully. So what I'm saying that is that 1, 2, 3, 2, 1, 2, 2, 1, 2, 3 is the reverse of nums, right? If I construct an LAS for this, I construct an RAS for nums. Carefully imagine this, right? Because क्या होगा? So like I had to make such a subarray like 1 2 or 2 3 2, right? So I can make it like this 1 2 2 3 2, ठीक है? And so simply to reuse this making LAS function, I flipped these two signs, right? Because carefully imagine, जो साइन यहाँ पे ऐसा लगेगा ना, 1 <2, when you reverse it, it will change the direction, right? So when you reverse it, it will look like 1 greater than 2. That is why I had to flip these positions, okay? That is why I had to flip this solution so that I can reuse the make alias function. So this is clear why I why I flipped the order, right? So just because I will reuse the make alias function uh, by using this property of reverse. Okay, so yeah, so 1 less than 2 is side will look like 2 greater than 1 when you flip the array. So the sign will change. That is why I flipped the signs here. Okay, so now you just simply have to imagine what you just have to focus on the making of LAS, right? Uh, so okay, till now if you have any problem, you can tell tell it to me in the chat box. Any problem, you can tell it to me. Okay, I don't think there is any problem. If you are not understanding, please tell me. If you're understanding, please tell me. I just want to know the feedback up to here so that I can continue. Are you keeping up with the pace? Are you keeping up with whatever I have told? Or is there any problem till now? I'm giving you 1 minute. Quickly tell me in the chat box if you can. Okay, so no one is writing in the chat box. So I will say, so make alias function, how will it look like? Um, so first of all, you initialize. If you look at the first index, so alias for this will be what? So you have to end it at 3. So obviously, कोई भी sign ले लो, you will have just one element. So I initialize with 1 comma 1. If the last tuple is greater, then also 1. If the last tuple is lesser, then also 1. Okay. And then I run a loop of size 1. So simply I'm writing that if I am greater than the last element, if I am greater than the last element, so what will I say? What will I say? If I am greater than the last element, तो पिछले वाले का I will take the lesser than and increase it by 1. And obviously, if I am greater, the lesser than wala will be 1, right? And similarly, if nums of I is less than nums of I minus 1, I will take the greater portion of I minus 1 and add one element to it. But the greater than portion this time will be 1 because this tuple has a lesser than sign, right? So this is how I make the alias. And finally, what if both are equal? If both are equal, you have to make 1 comma 1 because you cannot simply use the last previous element, right? If both are equal, you will make them both as 1 comma 1 and return the alias. This is more or less the implementation of the make alias portion. So I don't think you would have any problem in this. And finally, what I am doing, so this is alias equals to make alias, then you reverse, then you make ras equals to make alias, then you reverse the ras as well and the nums as well, so that the nums is returns to the original state. So you make the alias and ras now, and now answer equals to 0. First of all, uh, this will give you the answer if you do not remove any element, because if you do not remove any element, the answer would be simply either alias of I dot first or second, right? You will traverse the whole array and check it. And if I can remove one element, what will I do? Simply whatever I told you, right? Simply whatever I told you. This function, this loop that I told you. If I am lesser, then पिछले वाले का greater and अगले वाले का greater. If I am greater, then पिछले वाले का lesser and अगले वाले का lesser. And finally, take all the maxes and return the answer. So I hope this question is quite clear to all of you. It seems to be a hard problem at the first glance, but it is not that hard of a problem. If you have any doubt on this problem, you can write in the chat box. Otherwise, I will be ending the stream in 2 or 3 minutes. Um, any problem, you can tell me right away. Hmm. Okay. If you have any problem, you just tell me you have problem in make alias function, or you have problem in understanding the logic of how RAS is constructed. Okay, so someone has written understood the approach. Uh, Great if you understood it, because again, this is a lead code hard problem after all, right? So if you can understand the solution, it's very good for you. And this will come under the dynamic programming domain. If you have any problem in this loop, I don't think you will have any problem in this loop because I explained it thoroughly. You might be having some problem in LAS, make LAS part. If you have any, kindly tell me. I'm giving you 1 minute more. Otherwise, you can post it in the comment section after the end of the video. Okay. Okay. So I don't think any of you has a problem. So yeah, thank you for attending the session. I hope you enjoyed it. I hope you understood the concepts clearly. Still, if you will be having any doubts, I will be available in the comment section. I will be replying to each and every comment. you can write it. And please like the video so that I get some motivation to make more videos like this. So yeah, I don't think any of you has a problem. Even in the any other problem, if like in the third problem, I explained the OAuth login approach. If you have any problem in OAuth login approach or any problem in the OAuth n scale approach as well, you can write in the chat box. I will be ending in 1 minute. Okay, so yeah, great to conduct this session. Thank you for listening to me, and yeah, all the best for further contests.